Greetings everyone from the Real Space Program. I am NDEpics here, and welcome to the first showcase of the new Zeus launcher. The Zeus 311 configuration, carrying a 1.5 ton payload into low Earth orbit and then to semi-synchronous. Main engine start. We should have start of the Carolox burning RD-180. And we don't have SRB ignition, and we have abnormal launch vehicle staging. Staging needs to reset. Standing by for staging reset. That was an unintentional staging mistake. And now, I believe, we're going to rectify that staging mishap. And we have ignition of the RD-180. Gonna hear that roar to life in about a second. And ignition of the single AJ-60 SRB, adding about another 1,000 kilonewtons of thrust to the vehicle. And then the core stage along the core stage's engine can gimbal by about a vector of 8 degrees or so. Now, the only reason we're doing this configuration is the payload weighs almost 2 tons. It is a very high, well, that and the extra velocity needed to get into semi-synchronous orbit. While it can be achieved with the standard version of Zeus, the 301 version of Zeus, the 311 version of Zeus allows for much heavier payloads to be carried into semi-synchronous orbit. The Zeus 615, which is the most powerful of the Zeus configurations, can carry almost 4 tons to geosynchronous transfer orbit, and still have fuel left over in the second stage for for a second stage deorbit maneuver or additional maneuvers of that stage. Now, what we're doing here is we're watching the SRB thrust, and also watching the main engine thrust. So once we hit SRB cutout, it'll take a second and a half before the anticipated second and a half before the SRB is jettisoned, and I know this is taking a very shallow ascent profile. I should actually increase that to like 40 degrees. I should actually increase the ascent profile of the vehicle. And we have an unintended consequence of my screwing around with The shallower ascent profile was unintended. We did not intend to take a shallow ascent profile. In fact, we intend to take a 55-degree ascent profile with a final flight path angle of 15 degrees. So with this version of Zeus, we are able to power 1.5 to 2 tons to semi-synchronous, 1.5 to 2 tons to geosynchronous orbit, geosynchronous transfer orbit. When it comes to the larger versions of Zeus, Zeus is the most versatile launcher, flying with up to 5 boosters. And it can fly with either a 3-meter, a Type 3 payload fairing, or a Type 6 payload fairing. In the case of the Type 6 payload fairing, it replaces the inner stage with a complete overhaul of the upper stage, hiding the upper stage inside of the fairing. That version is typically only used for the largest payloads, such as anything that needs like 7.5 tons to GTO. Currently, it's only been rated for 3 tons to GTO. The Zeus's first stage uses a RD-180 Carolox burning engine. The booster maintains a rated thrust of 68%, and slowly increases that thrust as the vehicle experiences max Q, which has been experienced already. Actually, as the vehicle continues increasing in speed, it continues to increase its dynamic pressure. The spacecraft experiences Mach 1 at 1 minute 1 second after liftoff. Approaching maximum dynamic pressure, which is experienced at 1 minute and 10 seconds after liftoff. The Zeus MSLV, Modular Space Launch Vehicle, is going to be available to the commercial Kerbal market, the commercial market on that RSP hopes to open up to, putting satellites into various orbits. Typically, though, the Zeus will fly in it will typically use one of many configurations. This is one of the exceptions, because this is a experimental flight, and jettison of the single AJ-60 SRB. The Zeus combines the best of Atlas in its SRBs and versatile payload capacity and core stage, with the Falcon 9's high-efficiency restartable second stage. We did experiment using Soyuz engines on the second stage of the rocket, but those experiments did not go off as planned, just simply due to the fact of the matter. The core stage currently has another minute and 48 seconds left in the boost, in its booster burn. I believe it has a complete burn time of about 3 minutes, but it has 3 kilometers per second worth of delta V remaining in its in the stage. At 62 kilometers, traveling 1.5 kilometers per second. The Zeus launcher takes a very shallow, a much shallower ascent profile to it. At 102 kilometers, flying at 2 kilometers per second, the Zeus's core stage is throttled back to 48% in order to reduce G-forces on the vehicle. And depending on the orbit required of the vehicle as well, fuel levels can be tweaked in order to suit the customer's various needs. This is a flight demonstration. This is a flight simulation. That's why you can see all kinds of data covering the screen. We already know the Merlin vacuum engine is the most efficient engine that Real Space Program can use, unless you count the RD-180 engine. Now at 170 kilometers, with the RD-180 approaching burnout, firing its last few seconds of fuel at 100%, and staging the second stage and igniting the MVAC. With the Merlin vacuum engine lit, the vehicle can accelerate to speeds that are in excess and with the Merlin vacuum engine's excessive gimbal angles and its ability to gimbal it is able to accelerate along the horizon, pushing the 1.2 ton semi-SYNCOM payload, or better known as RSAT-1C. This is not a true mission representation. This is simply a mission objective flight. This is simply a flight demonstration using what is potentially one of RSP's future missions. This does not accurately reflect RSP's intentions or the goals of any future RSP mission. But getting inside of the science instruments, we can see we're getting 2 Gs of acceleration currently. You can see we've got antenna at the top and antennas on the side. What we're doing by pitching the second stage down is we're controlling our time to apogee and where our apogee is. Flying straight along the horizon allows us to keep our time to apogee high, but not so high. Right now we're communicating from Bermuda, and that means we can actually deploy one of our dishes. That will get a comms link. So we're sort of dragging our apoapsis down, and at the same time bringing our periapsis up. Keeping our apoapsis within the 350, we're within the 350 to 360 kilometer range as we throttle down the MVAC motor. To bare minimum thrust. And then we shut down the Merlin vacuum engine. The MERVAC engine performs potentially 2 to 3 burns, depending on mission requirements. If this is say this were just a low Earth orbit mission, it would perform 2 burns. The orbital insertion burn, and then once the payload was deployed, it would perform a deorbit burn. Now, on the far side of the Earth, we begin solar panel deployment, mainly so that once we reach the sunny side, gonna drag that maneuver along our orbit. Gonna drag it back along slightly. That way it gives us time to get oriented for the 2 kilometer per second boost up to the semi-synchronous altitude, of which this payload is hopefully intended to go. And the engine fires up for a little less than a 20-second burn. Raising the apogee. From 228 to 22,000 kilometers. Then we potentially could have enough delta V remaining in the first stage in the second stage correction to perform the semi-synchronous insertion burn. Aiming for a 22,000 kilometer apogee. The RCS is doing a little bit of assistance. burning RCS fuel of the second stage. Bringing the apoapsis right to 22,000 kilometers. Apparently it loses connection, which, oh, it has plenty electric charge. It loses connection for a few moments. I will upload this video to YouTube at a time that's convenient. Any assistance the second stage can give us in the at apogee boost maneuver is going to be much appreciated. Because after this boost maneuver, the payload's onboard thrusters, its 1 kilonewton thruster, must perform the transfer maneuver, which will potentially take several orbits and several burns. And now, having gone past apogee unintendedly, the MVAC is fired up for its last burn to give whatever assistance can be used to boost this payload into orbit. Now unlocking the Cavia tank aboard the payload. Anyways, that was just a demonstration of the capabilities of the Zeus launcher.